Good afternoon, everyone. I just wanted to show you a little picture of me here. I'm in the mountains in Peru. I'm on day 3 of a 5-day hike through the mountains, and I think I'm on the way to Machu Picchu here. Some of the Inca ruins that are located high up in the mountains in Peru. I always try to climb a mountain everywhere I go. I love it. They're really mystical, enormous things, and you never really know what you're going to find when you get to the top. So one of the things that is really related to mountains is this idea of slope. Okay, and so for this section of the chapter, we are going to talk about this idea of rate of change and this idea of slope. And so one of the things that we will come to understand is that our rate of change is equal to our slope. Okay, and the best way to illustrate this idea of what a slope is to think about mountains. Okay, so if I have a look at a mountain here, and imagine I was climbing this mountain. Okay, and I say I was starting right here, and I had to climb all the way up here. Okay, and I had to ask myself, well, what is the slope of this mountain? Okay, well, there's a couple things that I need to think about before I can actually say what this slope is. Okay, so I can I can connect this point right here. Okay, to say this point right here. Okay, so that I make a nice right angled triangle with my line. Okay, and there's a couple of things that we have to consider here, a couple terms that we have to learn. The first is this idea of a run. Okay, and so which way do we run? We always run on something that's horizontal. Okay, and so you can think about this horizontal line as being the run. Okay, and the run travels from horizontally from left to right. Okay, and this part going up and down we think about as the rise. Okay, okay, and so if I was going to make an exact calculation for the slope of this mountain or the slope of this line, we would have to consider these two ideas, the rise and the run. And we will, and a formula that we can use, okay, for the slope is the slope, okay, is equal to our rise, okay, over top of, okay, my run. Okay, my slope is equal to my rise over my run. Okay, my rise divided by my run. So once I know my rise and my run, I can calculate my slope. Okay, so if we really want to bring this beautiful landscape into the math world, let's drop a grid. Okay, right over top of it. And so I'm going to make my line again. Okay, I'm going to, just for simplicity, I'm going to connect it from this point here. Okay. And I'm going to go to this point right here. Okay, and a couple things that I need to calculate are my rise and my run. Okay, and so I can simply count that out. One of the things that you need to think about when you're figuring out your rise and your run are your starting points. Okay, so I'm going to go ahead and make my triangle. Let's make it orange so that you can see it. So I can draw a line. Okay, anywhere along here. Okay, and the arrow indicates the direction I'm walking. So imagine I was walking from left to right, and then once I get to this point, I have to change direction and move from this point walking up. Okay, so if I was going to walk here, we'd have to walk 1, 2, 3, 4 blocks. Okay, to the right, which is actually a positive number. So my run, okay, is equal to, okay, positive 4 because I'm moving from left to right, and my rise, right, once I start here and move here, I'm moving from this point up. I'm moving 1, 2, 3 blocks up. So my rise, okay, is equal to a positive, also equal to a positive 3. Okay, so if I was going to figure out my slope here, I start with my formula. My slope is equal to my rise over my run. Okay, and I state here that my rise is equal to 3. Okay, and my run is equal to 4. Okay, so the slope of this picture right here would be 3 over 4, or 3/4. Okay, if I have a look at another picture here, we can also um, uh, have mountains that go down. Okay, and so if I was climbing this mountain, okay, and I was starting here, I said, well, this is getting pretty easy. Okay, this is getting pretty easy because we are going down. Okay, and so if you're going down, we can always guess that we're probably going to have a negative slope, but let's just show how we can calculate that once again with our grid. Okay, so I have my grid here, and if I go ahead and I make my line, let's say we want to start at this point right here. Okay, and for simplicity, I'm just going to end right here to keep it nice and clean. Okay, and once again, I'm going to draw my direction arrows in. Okay, make a nice straight line going down. Okay, and then once I'm finished right there, I can make a turn and head this way. So if I'm starting at this point, I have to go down. So if I'm going down, I have to say that my rise is negative. Okay, so my rise here, okay, I'm going down 1, 2. So my rise is equal to -2. So once I arrive here, right, I can calculate my run. Okay, so my run is 1, 2, 3, 4. Okay, 4 squares to the right, which is positive. Okay, so +4. Okay, so once again, if I want to calculate my slope, it's equal to my rise over my run, which again, I can make my substitution here, which is a -2 over 4. Okay, and once I reduce that down, 2 goes into 2 one time. Okay, so we get a -1 over, and 2 goes into 2 into 4 2 times. So my slope reduced down to -1/2. Okay, so there's a nice introduction to this idea of slope. And I will come back. I'll make another video with a few more examples using different types of grids. Okay, I hope that helps.